So let's move to the correlations page to get a better idea of what we mean by correlation. Just go into the navigation bar, data mine, correlations. Here the segments are ranked from lowest to highest. The ratio from the training data is shown in blue, and the ratio from the validation data is shown in grey. The green line shows the number of cases, or the denominator, in each segment to get a feel for its size. For example, this segment has 370.95 cases in it on a weighted basis. The gambling addiction score from the training data was 0.06 and from the validation data was 0.015. This correlations chart looks pretty good since the grey bars line up closely with the blue bars. The blue bars are essentially our expected ratio or gambling score from each segment. When these segment definitions are applied against the validation data, which the algorithm had never seen during the segment process, the validation ratios in grey line up close to the training data ratios in blue. We say they have high correlation. You can see the lift, 1.28 up here, and the weighted correlation is 0.99 here. Let's go back to settings and push the model further by allowing it to have more segments. Now appears in this table. Each additional one we run gets added to this table until we delete it by clicking the delete button. If we click any of the runs that are in the table, the parameters that we chose for that run will automatically be put into all of the boxes over here and the text boxes and drop downs over here. Let's just demonstrate that by changing these around a little bit. Just picking random things. And then clicking this, and when we click this, all these values will be restored to these boxes and drop downs. There we go. So let's create a new run called Data Mine 2 with a lower minimum, say 20 cases per segment instead of 200, and let's just click run. It'll generally take a bit longer because it has more nodes or segments to calculate. Okay, we can see this model is significantly larger and more complex. There's a lot of different segments here. And if we just go to the correlations page, we can see that apart from there being a lot more segments, the lift is also higher at 2.18. But the correlation has fallen to 0.9. Generally, the lower the minimum node size, the greater the number of segments, or the greater the number of nodes, the higher the lift will be and the lower the correlation will be. So as the minimum size goes down, the number of segments goes up, lift goes up, correlation goes down. We can see here that there's obviously a lot more segments here. Generally, the blue and the grey follow each other less closely than they did in the earlier example. We can see down here there's quite a few segments where the grey is materially higher than the blue, and a few segments here, for instance, where the blue is materially higher than the grey. As a result, we have less confidence as to this segment's generalizability. You might want to play with the minimum segment size to arrive at a segmentation where the weighted correlation is in that sweet spot of 0.9 to 0.95. So this segmentation, it's okay, based on the correlation at least. It's at the lower end of what we would deem acceptable. Now there's just a word of caution here. Recall that we specify the training data to contain 70% of the cases and the validation data to contain 30% of the cases. Because this 70% is randomly selected from the whole data set, if we run a new data mine, for example called Data Mine 3, with the same settings, the segments, lift and correlation will be slightly different each time, because a different 70% sample will have been used by the algorithm in coming up with the segments. Just be aware of this.